In the previous example, we just saw the use of the SoundPool class for generating short bursts of sound, for example, for generating the explosion sound when the Android guy is hit by a bullet. Now let's examine the SoundPool class in a little more detail to understand how it all works. As we saw earlier, the media player class is a heavyweight class and it requires a certain amount of time for initialization before the sound can be produced. SoundPool class, on the other hand, is much better suited for situations where you need to produce sounds with a very low latency, as an example with a game. The SoundPool class basically allows you to specify a group of sounds or audio resources that will be managed by the SoundPool class. So when you specify these audio samples, then the SoundPool class uses the media player service to decode the compressed audio into standard raw full 16-bit PCM mono or stereo stream. And then it stores this audio information in memory. So that's the reason why the SoundPool class is able to produce the sounds with very low latency. Now, what this also means is that when you actually ship your application, you can include your audio files into the raw folder, and then when the SoundPool object is created, it will automatically decompress these audio samples into its full form and store it in memory for playback. Now, the SoundPool class allows you to specify several different properties. First includes the maximum number of sounds that it can play at the same time. In the example, we saw that we specified 5 as the maximum number of sounds to be played back. In addition, it allows you to prioritize the sounds. So at any given point, if you are producing 10 different sounds, and some of those sounds don't make much sense because they are dominated by other sounds, then the SoundPool class will allow you to specify, saying that if you need to play 2 different sounds, then you can specify priority for them so that the SoundPool will discard those sounds that have lower priority and only concentrate on producing the sounds that have the higher priority at that given point of time. And SoundPool allows you to loop sounds. Also, it allows you to change the playback rate, essentially meaning that you can change the pitch of the sound. So for example, from a single sound sample, you may be able to generate sounds at different pitches by simply varying the frequency of the sound. And also, SoundPool allows you to specify the stereo volume for the different stereo channels, the right and the left stereo channels. So this way you can give some spatial configuration for the sounds to be produced in your application. Now, if you look at both SoundPool and Media Player and ask ourselves, under what circumstances should you use one as opposed to the other, this table gives you a comparison between the two classes. Depending on what you are using your audio reproduction for, you should choose either SoundPool or the Media Player. So for example, if you require low latency or to play a short set of sounds many times, then you would resort to SoundPool. If you need to play a video or audio that has an audio track, or if you're streaming audio from an external source or playing background music, then Media Player is your obvious choice for playing music. Long playing audio is better handled by the Media Player class. Now we move on to the fourth assignment, where we are going to add more sounds to the shooting game. In the exercise, we saw that we added the explosion sound. Now, if the Android guy falls off the screen or if the bullet moves off the screen at the top, we're going to produce additional sounds to indicate these events occurring in your game.